live, I think. Okay, we're live. Okay, so it's still August. I just can't believe. Why are we in school in August? Anyway.
I don't know.
I don't know. Anyway.
Actually, I think we should.
And make school just like a week earlier.
You would get 10,000 signatures.
Okay, piecewise functions, right? So the first three, A, B, and C, are not piecewise functions. Just to review, I want to throw these back in so we have one more chance to think about it. So on A, okay, I totally agree, but also 0.
Yeah. Wait, so there can be a 0.
So if I factor, and I know you guys don't always factor, but if I factored, okay, do you agree this is the same expression but just factored? Here to here. Do you agree with that? Now, do you see I common factored out an x, right? Same expression. And what helps is this. If x is 0, the whole thing's 0, correct? But x can't be 0 because we would divide by 0, right? If x is 1, the whole thing is 1, or is 0. But we can't have 0, so x cannot equal 1. Now, you can see it too. I mean, if x is 0, think 0 squared minus 0, we're in trouble, right? 1 minus 1, we're in trouble, right? But x can also be everything else. A lot of kids forget the most important piece. Believe it or not, the most important piece is the domain. What can x be? These are the exceptions. A lot of kids forget to put this because the domain is really everything. The domain is everything except those two. Does that make sense? So it's really important you put in the all real numbers because that's what x can be, right? It can be everything except those two, okay? How about B? Let's think. Can x be 3? What's the square root of 0?
Oh, wait.
What's the square root of 0?
0.
That's okay.
So it
I'm all right
can
with
be
that. Can x be 2?
Yes.
X be 1?
Yes.
No. Yes.
Can x be 0?
No.
No.
Yes.
0? 9 minus 0 squared?
Oh yeah, I hear.
Can x be negative 1?
Yeah. No. Yes. I'm sorry.
Can x be negative 2?
Yeah.
Can x be negative 3?
Yeah.
But x better not be 4. What if x is 4?
That's too big.
Can x be negative 4?
No.
Yes. No. Gosh darn it.
So it's in between. So x is really in between negative 3 and 3. Okay, now what in the heck? Think about it. Negative 3 and 3, okay? So if x is 4, we're in trouble, right? If x is negative 4, we're in trouble. Now this one's kind of cool because if you look at the graph of it, let's see, all right, if you look at the graph of this one's pretty awesome. Clear, y equals clear, square root of 9 minus x squared, and graph it, right? It's a half circle. And it exists between negative 3 and 3, doesn't it, right? Cool, all right? How about C? Can x be negative 1? No, because then we would divide by 0. Can x be 0?
Yes.
Okay, so what we know is this. Can x be negative 1?
No.
But it better be bigger than negative 1. It's got to be bigger than 1. How about if we go t is greater than negative 1? Because it can be 0, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6, it can be 7. But it can't be negative 2, it can't be negative 3, it can't be negative 4, it can't be negative 5, and it really can't be negative 1 because then you have 0 divided by 0, okay? All right, piecewise graph. Now, if you learned this from me last year, then hopefully this will be easy, okay? Here's how I do piecewise graphs. These are my borderlines. Do you remember that? So the first thing I do when I do a piecewise graph is this. X, right? X, this graph is between negative 4, 1, 2, 3, 4, and I just draw in my borderlines, okay? Negative 4 and negative 1. So I'm going to have a graph between here. So I like to put my borderlines in first. I'm going to put this graph in between negative 4 and negative 1. Okay, does that make sense? Okay, I'm going to put this graph between negative 1 and 2. So I'm going to have this graph between -1 and 2, okay? So I put my borderline, okay? Remember that from last year? This graph we're going to go put in between 2 and 5. 2, 3, 4, 5, okay? So, graph number 1
Is it just 3 down in a straight line?
is going to be a straight line at -3. Totally right. Now, but what I'm not going to do, is bring it all the way across, right? Because it only goes in between here, right? So it's just that piece, okay? So I'm going to go ahead and put that in there, okay? So I'm going to do this. I'm going to go put my graph in right there, okay? Now, solid dot, open dot. Ooh, why do we, Zoe, nice job. Why do we put an open dot there?
Because there's
can
no
be.
line under the.
It does not equal -1, does it?
Yes.
So we put an open circle there at -1. Nice job, okay? This is a parabola. It's a parabola. And it looks like this. Okay, that's a really bad sketch. It looks like that, right? So it's -4. But it only belongs in here, correct? So let's put it in, okay? So I know that my parabola goes, it does this. We go down to -4. 2, 3, 4. Okay. Over 1, up 1. Over 2, 2 squared is 4, right? 1, 2, 3, 4. And I'm going to stop. I'm going to go back 1 and 1. Okay, so this is what I'm going to graph.
Wait, why did you fill it in?
I filled in this circle, didn't I?
Why?
Because there's a line.
Oh.
So I'm going to let this graph equal -1. At -1, this graph gets to equal it, right? Now, open circle here. Because there's no, does not equal 2, so it doesn't get to equal 2, right? Third graph, okay? X minus 2. Let's see, we start at -2 on the y-axis, right? And we're going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, right? Right? Except we don't have all of that line. We only have the line between here and here, so erase the rest. Sydney, is this starting to make sense? A little bit? These guys have seen this before.
Yeah, I've never done this before.
Okay, that's what I was worried about, okay? They've done this. That helps you guys a lot, right? So I'm only going to keep that piece right there. And it's going to go right like that. And I fill in the hole because it gets to equal it there, okay?
So
Now,
all of the holes are filled in?
not that one though. Now, it's really important though, and I'm going to put this up here and watch. This is super important that this, are you watching? Okay, it's a use your brain. This is really important that was not there. Super important that was not there. How come?
Because then you wouldn't be able to connect from the alpha to the
It won't be a function. What do you mean, smart girl? Can you count this point twice?
No.
And it's really important that you don't have it also here because you don't want to count that point twice. Either the point goes with this graph or this graph, but it can't go to both because then you count the point twice. So you've got an x value with 2 different y values. Can't do that, okay? All right, nice job. So it has to happen. Now, what about domain? How wide is our graph?
It's less than 4.
So it is going to be x is actually greater than, we're going to write it this way, greater than or equal to -4. Because it starts at -4 and slides over, but it's less than 5. Okay, you want to see a cool trick? Of course you do. Here is your domain. Isn't that helpful? There's your, doesn't that make sense? There's your domain. Because our graph went from -4 to 5, didn't it? There's your domain, really, right? There's our borders, went from -4 to 5. Now, what about range? We know what range is, right? Range, What's our range?
Negative 5 to... Is that negative?
What's the lowest value?
Negative 5, right?
I think it's 4.
Negative 4.
That's right. You thought you were on the right track. How about negative 4 less than or equal to y? What's our highest value? 3. Does it equal 3?
No.
There you go. There's your range. So Sydney, if you've never seen this, I promise I will help you, okay? These guys have all seen this before, haven't you? Yeah. Okay, ready to turn the page? All right. Now, take a look at it. Does not ask us to graph it, does it? Doesn't ask for us to graph it. It just says evaluate. So, negative 5. I've got 1, 2, 3 equations, right? Where am I going to plug? I'm going to plug it in, right? We're going to plug it in. We're going to plug in negative 5. I've got 1, 2, 3 equations. Where's the negative 5 going to plug into? The first equation. Correct. Why does it go in the first equation?
X equals 0.
Right. All right? It doesn't go in here because x is negative 5. It wouldn't go in there. It wouldn't go here because x is negative 5. It has to go in here because these are the x values that are going to be less 5. Yeah, Zoe?
So we're not looking at these.
We want to plug the negative 5 into here because this is an x value, right? That is an x value. Okay, this is like saying x equals negative 5. So where would I find that x value? There. So I plug it into here. So the answer would be 3 times negative 5. So f of negative 5 is equal to negative 15, right? So it's really easy. You just have to figure out where it goes, right?
Wait. So we are plugging it over there.
Yeah, so do I plug it into the first equation, the second, or the third? Which one do I plug it into?
Well, you plugged it in over there.
I plug it into this equation, right?
But you said what one would fit on the other side.
But yeah, you pointed to the other side. So wait, I'm confused.
Okay.
Wait, no, I don't need it. So what you were saying is there's 2 halves of the equation. This side and this side.
Okay, so this,
You're pointing to
let me flip the page. Can I flip the page real quick? Great question. Okay. So
I'm confused.
these are the graphs,
Yes.
right? And these are where the graphs exist, right?
Right.
So if I wanted, for instance, on this one, let's say I wanted f of negative 2, right there, the answer would be negative 3. If I wanted f of 4, 1, 2, 3, 4, the answer would be
Oh,
2. You with me?
yes.
Now I don't want to graph it because it would take, I could graph this, right? I could, and I could get my answers that way, but why not make it faster, okay? So, let's do this one, 0. Do I plug 0 into the first equation, second equation, or third equation? Where does it fit? Second equation. Because 0 would be greater than or equal to 0. 0 would fit right in here, agree? This value would fit right in here. So take 0 and plug it into your second equation. So f of 0 is going to be 0 plus 1, which is just 1. All right? F of 2. Okay, so where does 2 fit? Am I going to put it in the first, second, or third equation?
Second.
Okay, starting to get this? Okay, starting to get this? Second equation. It doesn't go into this one because it doesn't equal 2, but it goes to the second equation. So let's plug it in. F of 2 is equal to 2 plus 1, so f of 2 is 3. Catching on?
Yeah.
F of 5, where does that go? First, second, or third? Third equation, because 5 is definitely greater than 2. So 5 has to go into the third equation, so I plug it in. F of 5 is equal to a 5 minus 2 squared, which is 3 squared, which is 9. There you go. Okay? Okay, now, you just got the exact same sheet. We've got 5 problems that